All right, hello and welcome to another class with your favorite math teacher, Sanchez. All right, we're gonna go over lesson 2-4 in our book. That's our Springboard Algebra 1. We're gonna be going over equations with no solutions or infinitely many solutions. That can mean a lot of things in math, but we're gonna focus on it today. We have our learning targets, and our learning targets are pretty simple. We need to be able to identify equations that have no solutions, and I'd be able to identify equations that have infinitely many solutions. All right. And then so far up until now, every equation we have solved has only had one solution. So only one number that makes that equation true. But before we begin, we got to do a little bit of review. Remember, the solution of an equation with one variable is the value of that variable that makes that equation true. And I already highlighted this stuff right here. That's the solution, all that stuff. All right. So basically, it's a value that makes that equation true. An equation is true when both sides of the equation have the same value. Otherwise, the equation is false. And I have some examples already written here. All right. So in this case, right over here, if you look over here, we want to check if x equals to 3 is a solution to the equation 2x minus 2 is equal to 4. Okay? So what we do is to check if something is a solution, if you remember to back to our lesson 2-1, all you got to do is plug in this 3 wherever the x would be. In this case, it will be right here. And we just evaluate the equations, right? So 2 times 3 is going to become 6. 6 minus 2 is 4, and 4 does equal 4. That means that this equation is true. Therefore, x equals 3 is a solution to the equation, okay? So that's how we determine it. If something is not a solution, so right here we have another example. It's the same equation. We have 2x minus 2 is our equation, and we're checking if x equals to 1 is our solution. Well, to find out, once again, like we did before, we're just going to plug in this x equals 1 right here, wherever the x would be, is 1. And we're going to get 2 times 2, which is 2, minus 2. What's 2 minus 2? Well, that's 0. Does 0 equal 4? No, that's a false statement. That's why we put a slash right here through the equal sign, because that is not a true statement. And right here, we would say that the equation is false. Therefore, x equals 1 is not a solution. And you can just see that I wrote that down right over here. Right? So you're like, Sanchez, you're going over all this stuff. We already know what a solution is. So you said we're talking about infinitely many and no solutions. When are we going to get to that? Well, I'm glad you asked, because I'm just going to show you 2 examples, and then they're very similar to each other in the terms that once you see what we're doing, you're going to understand that that's going to be the case for all equations of that type. All right. So right here we have these two problems. It says determine whether the equations have either infinitely many solutions or no solutions. So off the bat, I'm telling you they already have it's either one or the other. It's not gonna have just one solution. So all we're gonna do right now is we're just gonna go ahead and solve for the problem. Yeah, that sounds good to you? Sounds good to me. All right, so let's start over here at equation 1. All right. So we have 3 times quantity x plus 4 minus 10 is equal to 3x plus 2. So first things first, we got to do our order of operations. We got to take care of this parentheses slash multiplication, okay? So we're going to distribute the 3 over here and over here. So we're going to get 3 times x plus 3 times 4. And then we're going to keep the rest the same. So we're going to keep that in black, okay? It's going to be 3x plus 2. When we simplify, we're going to get 3x plus 12 minus 10, and then the rest is going to stay in black, right? Minus 10 is equal to 3x plus 2, right? So we're up to here. And so now what we got to do is combine the like terms. 12 minus 10 is going to be 2, and then everything else stays the same. So we're going to have 3x plus 2 is equal to 3x plus 2, right? So we have this much, right? So now that we've made it here, normally when solving for x and you have an equation on both sides, normally I would tell you guys, subtract whichever x is smaller. But in this case, you're gonna notice what our x's are actually the same value. What are we gonna do? Well, we're still trying to solve for x, and what we're gonna do is we're gonna subtract x from both 3x from both sides. Why? Because our goal is still to try and isolate the x by putting it on one side, and you're gonna see something interesting happens here. So we're gonna try and move this x over here, right? How do we do that? Well, we gotta do the opposite of addition, which is subtraction. So we're gonna subtract 3x from both sides, right? And you're gonna notice here, this 3x cancels. We're gonna get 0 and 0, right? 0 plus 2 is 2. And the same thing's gonna happen over here. 0 and then plus 2 is 2. Notice here we get this as our answer. 2 is equal to 2. Is that a true statement? Well, yes, it is. Because we get a true statement like this, so because we get a true statement after eliminating the variable, so because we got this statement, a true statement after eliminating the variable, this equation has infinitely many solutions. Infinitely many solutions. All right. And that's the answer. Our answer is that the equation has infinitely many solutions. What does that mean mathematically? What that means is that no matter what you plug in for x, it's always going to be true. It doesn't matter. You can plug in 0, you can plug in 1,000, you can plug in negative 554. No matter what you plug in over here, you're going to get 0. And I can show you, right? You can even determine this right here. Look, we have 3x plus 2 is equal to 3x plus 2, right? These two things are the same value, right? So we're plugging it, if it's 3x here and you plug in 0, you're gonna get 0 plus 2. And you plug in 0 here, you're gonna get 0 plus 2, right? It's gonna be the same. You plug in a 2 here, you plug in a 2 here, it's gonna be the same thing. So once a trick that I remember is if you can make is while solving for the equation, you get something that equals to itself. That's how you know it has infinitely many solutions, okay? And that's like a trick, but really you're gonna end up all the way over here, all right? And if the statement is true, infinitely many solutions. So we're gonna go ahead and go to our next problem over here. Our second example is gonna be pretty straightforward, very similar. It's 2 times quantity 4x plus 3 minus 3x is equal to 17 plus 5x, all right? And so what we're gonna do is, once again, we're gonna take care of the parentheses and we're gonna distribute the multiplication of this 2, right? We're gonna have 2 times 4x plus 2 times 3, and then everything else is gonna stay the same. So minus 3x is equal to 17 plus 5x, right? Next, we're gonna try and simplify some of the stuff on here. 2 times 4x is 8x, and then 2 times 3 is 6, and then everything else stays the same. And now you're gonna want to combine the like terms. What are the like terms here? Well, right here we have an 8x and a 3x, right? Negative 3x. You're gonna want to combine those. And you're gonna end up getting 8 minus 3 is equal to 5x. Oops, and I don't want to write that in black, I want to write it in red, right? And then everything else is gonna stay the same. We're gonna have plus 6 equal to 17 plus 5x. And once again, we're going to end up here where we want to get x on one side of the equation. Unfortunately, right here, you'll notice that we have the same value for x. So we're just going to subtract 5x from both sides because we don't have a smaller value, all right? And so when we do that, you're going to notice we get this statement. This becomes 0, so you're going to get 6 is equal to 17 because this also goes to 0, right? All right, is 6 equal to 17? That is never true. This is a false statement, right? This is a false statement. This is a false equation. And because we've isolated the variable and we ended up with a false equation, well, what we can determine is this equation has no solution. So basically what this means is that the equations are never going to equal to each other, no matter what value of x we plug in. All right. And as we get on later on in the semester, we're going to learn how to graph these. And if you were to look at the graphs of these equations, there are lines that are never going to touch because they're parallel. But other than that, that's basically it. That's all we need to learn for this lesson. You're going to have some example problems on Edpuzzle. You probably already done them. But other than that, all right, guys, if you need help, remember, show up to the Zoom sessions, ask questions in the discussion groups, or just direct message me on Schoology. All right, have a great day. Let me just pause the share. And that's it for the lesson.